Hello. Right now we're going to simplify a rational expression below while making sure that we also state our restrictions. So in this case, I have the rational expression, the quantity 6x cubed minus 15x squared minus 36x, all over the quantity 2x to the fourth plus 5x cubed plus 3x squared. Now, since we want to simplify, that means we want to factor. So at this point, you should be able to factor with ease, I should say. So since I want to factor, the very first thing I always want to think of is there a GCF? First thing I want to think of is there a GCF, a greatest common factor? If I look at my top expression, 6x cubed minus 15x squared minus 36x, you can notice two things. First of all, there is at least one x in each of the three terms, but also if I look at 6, 15, and 36, those are all multiples of 3. So in this case, if I think GCF, I could factor out 3x from my top expression. If I think about factoring that out, that's going to leave me with 2x squared minus 5x minus 12. My separation bar. Thinking the same thing for the bottom expression, if I look at the coefficients, I have 2, 5, and 3. Nothing common with them. Can't do anything with that. However, looking at the x's, I have 4, 3, and 2, so there's at least 2 x's in each of the terms, so I could factor out an x squared. This will leave me with 2x squared plus 5x plus 3. Now, that is just the first step. Now we need to go back and revisit these new factors we have come up with, these quadratic trinomials, and factor more. So that's going to be my second step. Factor the quadratics. Okay. So to illustrate the factoring of a top expression, I'm going to bring this over here. Now, I use what's known as a tic-tac-toe factoring method, what actually looks like a tic-tac-toe. Now, the three values within my quantity here, 2x squared minus 5x and minus 12, those are each going to fill in the top portion of my tic-tac-toe. But the order is the two terms in which we factor and then the one in the middle, because we're factoring 2x squared, we're factoring negative 12. We need to make sure whatever we do combines to become this minus 5x. So then comes where I need to break it down. Well, x squared I know is x and x. 2 has to be 2 and 1. So I could put a 1 there, or I can omit it and just write x. So now comes the part where we need to figure out how to break down 12 in such a way that we will arrive at negative 5x. So, if I think possibly a 4 can go there, 3 here, 4 times 3 is 12. Since I have a minus 12, one of these values has to be negative. If I apply the negative to this 4, let's see what happens. So now comes the point where I need to multiply across. X times 3 is 3x. Multiply across, 2x times negative 4 is negative 8x. And then I check to make sure these two terms combine, meaning add, to equal negative 5x, which in this case they do. 3x minus 8x is negative 5x. So I have now discovered my factors. Here's the biggest key to this factoring method. In the end, my factors are contained within these 4 squares. However, I must crisscross. So that means this top expression can now be written as 3x times the quantity of 2x plus 3, since we have a 2x and a positive 3, times the quantity of x minus 4, since I have an x and a negative 4. I will illustrate the same for our bottom expression. So again, I get to set it up. 2x squared, 3, then 5x. 2x squared, 3, 5x. So again, 2x squared is going to break down as 2x and x. 3, my only real option for 3 is 3 and 1. or 1 and 3. Multiply across, x times 3 is 3x. Multiply across, 2x times 1 is 2x. And again, these two terms add to equal my 5x. And thus, we have now factored this bottom. Again, I have to crisscross in order to determine my factors. So we can now write it as x squared times the quantity of 2x plus 3, since it's a positive 3, and x plus 1, since it's a positive 1. Now that everything is factored completely, we're to the point where we want to simplify. However, before we can simplify, we must state restrictions. The restrictions come from our denominator. So if I look towards my denominator, I have 3 terms I need to be worried about. If any of these 3 terms is 0, that makes the whole denominator 0, and as we know from all mathematics, we can never divide by 0. So if x squared cannot equal 0, then our first restriction is x cannot equal 0. If I say 2x plus 3 cannot equal 0, with a quick 2-step equation, divide by 2. So we have x cannot equal negative 3/2. And then finally, x plus 1 cannot equal 0. Simply subtracting 1 from both sides. X cannot equal negative 1. So these are our 3 restrictions. Again, because, x cannot equal 0. Again, because our denominator has these factors, if any of these values are 0, the entire product is 0. Now comes the point where I want to actually simplify, finish up the problem here. So if I just come back over, I want to look for things that match. First of all, 2x plus 3, 2x plus 3. Those match, so they're gone. I have an x in the numerator, 2 x's in the denominator. So by exponent rules, I could take 1 away from these 2, eliminating that one. So at this point, we have canceled everything we can, so it comes to the point where we write what remains. So I'm going to come down here, and so far this all equals 3 times the quantity of x minus 4 over x times the quantity x plus 1. Now, in most cases, you could just leave it like this in factored form, but sometimes it will want you to distribute and simplify. 3x minus 12 over x squared plus x. So this is my final answer with my 3 restrictions. X cannot equal 0, cannot equal negative 3/2, and cannot equal negative 1.